Welcome back to the Just Build Baby Studio. You're listening to the BuildX Podcast, your ultimate guide to creating exceptional homes, innovative living spaces, and staying informed on all aspects of residential building technology. I'm your host, Buzz Artiano, and together we'll explore the strategies, techniques, and insights that transform ordinary houses into extraordinary homes. Today, we're excited to have Alex MacLean here, not to be confused with John McLean from Die Hard, in studio with us. Alex is the Northeast account manager for AeroSeal with over a decade of experience in energy efficiency industry. Welcome, Alex.
Thank you.
Good to have you here. So normally what we like to do is just kind of give the audience a sense of who you are and how you got started. So don't take us back to when you were in the hospital, but kind of take us through your professional career.
So graduated out of UMass Lowell, got a degree in civil engineering. So I've kind of always had a mind towards the construction field for the most part. Right after I graduated, I took that opportunity to jump into the construction field directly. So I joined up with a luxury home builder within the 128 loop. So right in first project right in Lincoln, Mass was actually where I joined up with them. So I came on as a assistant project manager, but it was a relatively small team. So a lot of hands-on applications within this, outside of just the general, project scheduling and project management aspects. Also, firsthand construction experience.
Okay, and this was a luxury home builder, like a production builder, or you were building for customers?
Building for customers. So, working alongside the architects.
So custom builders.
Custom builders. So yes.
Lots of details, lots of nooks and crannies, lots of plans.
Yes. So right off the rip, that's where I landed, and it was mostly because I wanted to have a bit more of a hands-on application versus just more so into the kind of desk work type of job that you could wind up in, or just some data collection or something like that.
Got it.
I did that for a little bit, and then I actually went over to the Mass Save program. So I was working with a company that was offering that type of field, and I spent a lot of time basically working through a few different positions there. So I did everything from home energy audits through different types of account managements within that company as well. So
you were going into houses in the beginning and then moved your way up inside that company.
Yes. Yeah.
Wow.
So I mean, I've a couple thousand homes at least within that same area, within 128 loop. So I mean, it was a daily adventure into each and every one of these homes, crawling through crawl spaces, just looking at these homes and then recommending whether it's an insulation package or helping them out with their lighting or mechanical system upgrades. I'd assume most people that tune into this, they're very well aware of the Mass Save program and the types of things that are offered through that program.
Well, let's explore that a little bit, because I don't know everybody knows what. So maybe just a little sidebar. What is Mass Save and what do they do?
So, Mass Save is it's a utility sponsored company, or program rather, and there's a handful of companies that are operating throughout the state. And usually you'll receive something in the mail that says, "Hey, no cost energy audit of your home." So that's kind of the baseline of what are we doing in the field for at least the largest part of what everyone's involved with.
So that gave you a lot of hands-on experience crawling and looking at a bunch of older, newer, whatever houses that had deficiencies in some way in energy efficiency.
Yes, yeah. And then, I mean, specifically kind of in the greater Boston area, you're going to deal with some of the oldest housing stock, in the state, but, and that kind of transfers to the nation as well. So definitely lots of areas for improvement, rather, and you're seeing everything through different decades of, what type of building materials were used, how were these constructed.
So you saw everything from no insulation to newspaper insulation to cellulose to mineral wool to the old fiberglass bats that are about an inch thick now.
Yep.
You saw it all.
Yes. Yeah. And so and after doing that for a while, I moved from the kind of residential side, or rather, it's all residential in terms of where I was falling into that program. But I moved from single family into the larger scaled multifamily types of buildings, and construction gets mostly, it was a little bit newer on that, kind of front end. And then it's all still kind of the same game of what's the existing structure, how can we check this thing out, what types of improvements could we actually apply here, and then it transferred through a few different modeling programs that you'd use from the kind of standard home audits into more kind of specifically dialed in ones for some of these larger buildings. And, and with that changeover is a whole ton of different types of mechanical systems and where these savings could actually be had.
Interesting. Okay.
And then within all that, though, typically lowest hanging fruit was going to be, how's this thing insulated?
Sure.
What's the envelope made of? And how porous is it? So that's
cutting down on air changes is number one priority.
Cut down on the air changes, because then you're going to mitigate and reduce how much air you're actually conditioning in any space.
Got it.
So, and that's
so that's the biggest bang for the buck.
Easily, it's the biggest bang for the buck. Yes, and that's on two fronts too. It'd be on the envelope, so the shell of the structure, but it's also going to be on the distribution systems within those structures.
Okay, so leaking duct work.
Yep.
All that.
Yep.
And obviously makes the house more comfortable for the occupants. Right?
Yes, and that was that's every so often you get a call back from a client that you went to, and they'd give you the follow up of I'm so glad that you came here and helped me out
Awesome.
with that. So that was always kind of part of it.
Yeah.
But mostly it was just how can we reduce reduce BTUs, reduce kilowatt hours, reduce gas usage, anything across the board. And then as I was working in there, I once again, I had a little bit of experience with different types of modeling platforms that we were offering for these upgrades, and then monitoring projects and scheduling them out with different clients. And then from there, I ended up coming across a posting for a smaller outfit that was getting involved with AeroBarrier that you see there. So that's where, once again, it's the explanation is, we're looking for the right candidate that can come on, essentially try to help build this this part of our business, while also maintaining a bit more of a customer relationship with our existing clientele that we currently have under.
So account management and new client acquisition.
Yes, so exactly that, but also operating as more of the energy consultant.
Okay,
for their
so technical advisement
so
as well.
Technical advisement,
Yep.
yes, and this was based out of Rhode Island. Where their energy code wasn't, quite the same as Massachusetts,
Sure.
where, normally the first person involved in Massachusetts, it's going to be your HERS rater, and that's just across the board.
Right.
They need to be involved from the get-go. So, in that area specifically, they had a bunch of clients that they acted as kind of the liaison when it came to just general energy consulting on their projects. And then once again, they had an existing business structure. They wanted someone else to come in and kind of start working on this portion and brand in that half of the company.
And so this was a technology that they invented, or they bought a franchise for? Or?
So initially they had bought a franchise for it. So it's
Okay.
with 5-6 years ago, there was only one or two of them that were out there at that point. So it's one of the original franchisees in the New England area. So it just wasn't quite as common at that point. And just reading over it and kind of going through it, a lot of people's first, I guess their first introduction to the system is, hey, I saw that on an episode of This Old House.
Sure.
So it was a project down in Jamestown, Rhode Island. So and that's usually, it seems cool, seems, it definitely, I'm not sold on how it works or anything like that. But when I read through it, and it just there was a light bulb that had clicked in my mind that says, it makes perfect sense to me. And especially just with, just some inconsistencies across a lot of building through in the scope of the air barrier.
Sure.
There's a few different ways you can go about it, relying on spray foams or other, or hey, we have this system that explained is at the very base level of it is it's just kind of like fix a flat for a tire.
Sure.
So you can just apply that to your home at this point. So you got an airflow that's escaping under a pressurized environment. You fog it with a sealant or fill it with a sealant in the case of the fix a flat. And it's just going to find the penetrations for you.
Right.
So instead of kind of going through some headaches at different points in construction, you can effectively run this, and you can tie it directly into any one of the blower door kits that are kind of out there that most raters use. The system itself is operated through means of a blower door. I believe it's probably the RetroTech system that's actually inside the system. So in real time, you're actually watching airflow throughout the house.
All right, hold on to that thought. We're going to explore that. So now you've got to a new company. Mm-hmm. You brought in for one role. Take us through how you got to where you are today.
So I guess it kind of started just joining up with this one. I came in, I was working on just trying to develop business, mostly in regards, that'd be the bread and butter would be the AeroBarrier. So And then alternatively, just the other, once again, modeling and consulting and other offerings, compliance testing in the state of Rhode Island, things like that. So in that time, I worked mainly targeting a lot of high efficiency builders. It's the way that it ended up playing out was that Massachusetts was already kind of dead set. Their standards were there. Everyone had been building to it for well over 10 years, a decade at this point. It's 3 air changes an hour was the number you hit, and that got you to your required HERS rating scores. So general building, this didn't really have much of a place in there unless it was a fail-safe at the end game where they weren't going to get their CO.
Sure.
And it's a very time-consuming and costly process at that point.
That's like the last resort. You're at 4 air changes an hour and you can't find something obvious.
You can't find it obvious, and your HERS rater is holding you to account, and you're not getting that CO, which at the end game, that's
someone's got to move in to pay for it.
Someone's got to move in. So, so a lot of the time was spent. One, it was targeting those types of builders, high efficiency builders, passive builders, the Energy Star builders, things like that, as well as a ton of just basically, community outreach and teaching. So, the system itself, a lot of people would just say, I get it, I get the concept, I understand it, but, they want to see it actually happen and occur. But when you're telling someone, hey, sure, it's not quite necessary here, it'll cost you a couple $1,000s in their build profile, and they go, okay, no thanks. So it was really trying to focus on passive house and those types of builders initially, kind of off the.
So those were your early adopters.
Yes, those were the early adopters, and through those types of builders, and kind of obviously just networking and outreach to any other area builders that you'd talk to a lot of people. They'd say that sounds very interesting. Let me know when you have something going on in the area and I'll swing by. And then, so it's, just kind of one step to the other. You're working through trying to develop a little bit of a pipeline under those means. And then alternatively tracking down, tons of architects or other, because once you get into those larger types of builds, multifamilies, things like that, the first thing they're going to look at is the spec sheet or what's on the drawings here. Sure. And, they're typically going to follow that to a T. So,
and so what's your role now at the company?
So right now, just kind of Northeast account management, I'm just kind of continuing the relationships that I've built over the last few years. I'm doing more of the, the shows like JLC that we spoke at, and then, any types of events like that, or, also just outreach to builders who, I guess the biggest change was the most recent energy code requirements that went into effect. So, that kind of brought the baseline builder kind of into the realm of...
they had to respond because now they have to meet, whatever the air changes an hour has been designed at.
Yep.
And, doing it the old way is not going to get you there anymore.
Yes, and then it's also just how can it play into a build profile? So, sure, you can spray foam the entire envelope of your structure. Now, and that works great for the builders that have clientele that can, shell out an extra $10,000, $15,000, $20,000. Depends how big the project is, but that's probably a realistic dollar amount on just your insulation profile.
100%. Yeah.
That's not taking into account everything else that they already need to change anyways to meet this new energy code. So that's where this system is able to play a very, easy kind of implementation into their build profile. Within a day, you can typically take most homes, especially if they're building them at least to like a 3 or something like that, or 3 to 4 range, if that's where they're consistently at. Usually, it's a one-day process, and you can guarantee, or not guarantee, but you can leave them with a product that's at 1.5. The guarantee comes on them staying on top of things once you're also out of there anyways.
All right, so let's explore that. So now let's get down to the meat. So explain first what the system is, how it works, and then we're going to talk some scenarios.
So the system itself, it's an aerosolized acrylic, waterborne sealant. So you get it. It comes in.
Stop you there. So
sure.
There's no VOCs, nothing harmful. So once it's sprayed and dried, it's inert.
Correct. Yeah. There's no off-gassing, ultra-low VOC content, UL Green Guard Gold certified. So it has all of the markings of a product that's able to be used in any form of construction, whether it be a hospital.
So someone has an autoimmune disease, or they're sensitive to latex or whatever. Once this product is installed and dried, What's the dry time on the sealant itself once it's found its way to the cracks?
So, I mean, it essentially it adheres, almost immediately as it's in process. It's adhering to the cracks.
So it's 20 minutes to an hour. It's pretty much done.
20 minutes to an hour. It's essentially done. In regards to the actual, the building itself, in terms of when you would walk in after the fact, half an hour. You just got to give it time. It just has to settle. So, I mean, it's not off gassing. It's not leaving, anything like that.
So nothing harmful. We don't have to worry about someone getting sick after the fact, having some allergic reaction to it. Once it's in and done, it's over with. Obviously, you don't go inside when it's being sprayed because it's all aerosol, and you don't want to get that in your lungs because it's going to stick to your lungs, right?
Yes, yeah, not without a full. You can certainly walk in. You can use a full face respirator.
Proper equipment, but not open mouth. So it's aerosolized. How do you force it to get into all the cracks and nooks and crannies?
So that's where the blower door comes into play.
So we're pressurizing the house.
Pressurizing the house, yes.
And what's that level of pressure we're applying?
So, I mean, baseline typically it can depends where the house starts. Ideally, you're going between 100 to 200, honestly, pascals. So that's just the rating for pressurization within the building. And to think about it this way, it's your standard blower door test. If you're running a multi-point test that's happening on any general construction, they're going to depressurize the house to 50 pascals. So we're doubling that or quadrupling it in some cases.
Okay, so you will adjust that depending on what your initial reading is.
Yes, yeah. So and it also depends on how large the structure is. So fans, it depends. Where does it start? Where are you taking it to? But it's mainly on the building itself. If there's a giant gaping hole somewhere that no one's seeing, you're going to try and pressurize it, and you're just going to get a red screen that's on your door, and it's just not going anywhere. It's not
now you got to find the hole. Right.
So now you got to track and find holes, which that's what this system does for you anyway. So
let's talk about that. So you show up, you cover the bathroom fan or the hood vent or whatever, the obvious. Now let's talk about that. So we want to do this when we're at drywall hung plaster finish, correct? Ideally,
yes. I'd say it varies on structure to structure. There's definitely some nuances that go into the actual application.
Let's talk about that.
So I'd say general construction, if you're going to build a home that has no hot roof, so you're looking at just sheetrock in that ceiling, it's going to be filled with R60 cellulose at this point, probably with with the new code compliance. Then we need that sheetrock ceiling to be installed first because we need an envelope that can actually be pressurized.
Okay. So what if we're doing a hot roof? Then we can do it at any time?
So if you're doing a hot roof, well, then it would also depend on what the exterior structure is. So, I mean, yes, you can get in pre-sheetrock, pre-insulation.
I'm saying, so we could insulate, if we're let's pretend we're spray foaming and doing bad on the walls and spray foaming hot roof.
Yep.
And so once we're insulated, we could run your system.
Yes. So as soon as you blow in that roof line, so as long as that is fully encased, then that's giving you some access right to that exterior sheathing.
Right. So at that point we can pressurize the house.
Yes, and obviously you'd have to be weather tight. Windows have to be installed, and then we'd say, hey, if you're going to have an ERV or something tied in here, not that it needs to be online, but wherever those vents are going to be ducted out of the house, it's in your interest to make sure those things are fully cut in first. So, So all exterior penetrations have been made.
Right. So you're done. The exterior envelope is 100%. We're fully insulated. All our penetrations are done. All our wires are poked out. The gas lines, or gas or electric lines poked out, or water line, whatever it is, sill cocks are out. Everything's done. Yep. So there's no more monkeying around with that envelope. Mm-hmm. That's the time to get you in. And it can either be insulation complete or sheetrock complete.
Yes.
Or in my case, plaster.
Yes, and I would also just say the only thing that I would say is that typically if it's, depends what you're going to do with your wall profile. So sometimes it's going to be a net and blow, or it could be fiberglass, rock wool, or anything like that. Then I'd advise that you either do it before that actually gets installed or after sheetrock if it does go in.
Okay, all right. So that's a nuance there depending on what the insulation is in the walls.
As you'd imagine, some of those cracks that you're fighting against when it's the exterior sheathing, once your insulation is in that wall cavity, it's a partition towards the exterior envelope. You pressurize, it'll filter into some of that. Someone pushes on that stuff, it could release.
So these spray heads are spread throughout the house?
Yes. And it depends. There's a few different systems that are out there. The more recent system, it has it's the Connect and the Select systems, but they're basically individual seal stations that you can, looks like a travel suitcase or a little protective suitcase.
So it's not even a central pump anymore.
Not even a central pump. No. So each one of those individual units will have its own pump. It's going to have its own humidity and temperature sensors. And then so each one of those will basically have like its own little 2.5 gallon bucket pail that you can put inside of it. So
These are battery operated.
So yes, they're battery operated. They'll communicate through a little mesh Wi-Fi network right to your computer or the MCU as well that's working with it. It's similar to the older system, but just kind of similar but
so
different.
Each one of those will cover a certain amount of area.
Yes.
Or if like, okay, well, we're transitioning here, we need one here, and so you set these up, and then you turn the blower door on, and it says, let's pretend we need to get to 1.5, and you see 2.75 on the screen.
So yeah, so 2.75, 1.5 is your end goal target, and that's where your HERS rater needs this thing to test out at, as they're doing their third-party final testing. So, they're not going to run with the number exactly that we have.
They're going to run a test again at the end.
Yeah, they're going to run a test at the end. That's when they do their final inspections. That's when they run their testing. So, that's where 1.5 is your target. We're going to go below 1.5 typically.
Sure. So
safety factors. Your windows are getting taped up. Your bath fans. Any dedicated ventilation. It's all getting taped. And even when they have dampers on them, they're still going to leak a little bit. Sure. That's just 100%. The nature of construction at this point. So there's just a couple factors.
So you'll take
safety.
it to what, 1.25?
It could be 1.25. It could be 1. It's really the first time you kind of unload a client and you're trying to figure out exactly what's going on. You can do it a couple of ways. You can either really blow the tolerance out with the guys in the field as they're going there and really drop it below, and then do some follow up later, see how played out with your HERS raters.
Okay, so it's a little dependent on what you think's going to happen.
Yeah, so because any window package, they're going to come with their factory ratings of a certain leakage rate per square foot effectively that it takes up. So that can give you a ballpark estimate, and someone has a dent on their metal flap on their vent flapper. So now instead of that thing having leaked at the end game, if it was nice and flat and flush, 5 to 10 CFM, it's leaking 20 or 30 by accident, which, once again, that's your HERS rater would just tell you failed. They might, if they visually see it outside when they're running the test, they'll say, maybe that's your problem. But other than that, they're just going to tell you, hey, you're failing. You need to do something to rectify this. Call me back once you take care of it. So you
take it a little below the threshold.
Yep.
And can you tell right away as you're spraying this product, you're like, okay, this how you're seeing this in real time, the change?
Yes, so yeah, it's going to
instantaneous, or
it'll plot it every 60 seconds. It's going to plot it for you. So
okay, and you can see how fast you're getting to your goal.
Yes, so yeah, and you'll watch it and you can see the drop, and then once again, then all of a sudden you're kind of going back to, how long does it take? Some houses are quicker, some houses are shorter. It depends on exterior conditions. There's a whole bunch that kind of goes into it that you just kind of learn from experience to an extent. But yeah, in real time, you'll actively see where it started, where it's going. Once again, what you get from the certificate, in my eyes, is it's a good starting point just to at least gauge how everything is operating in the home. It's not going to be the exact reading though, in terms of where your HERS are coming from and things like that at the end game.
So now we've blown the product. We're confident we're at 1.25 or 1, depending on what you've decided. How much product have you sprayed typically in a house to do that? Is it a gallon? Is it 10 gallons?
So that's where it comes. I mean, it depends how big the cracks are. It depends how, if you have a long-standing, sometimes that it's worked out in the field is that there is that gap that's, maybe like 2 inches by 3 inches, and that's just a hole. It's a little too big for this thing to cover ground on, but you don't know it.
Well, so that's a good question. How big a crack will it cover over?
So I mean, about 5/8, ½ inch.
Really?
That's what it can cover. However, in our eyes, if you can see something that big, then you can take care of it and minimize the recaulk.
Yeah, but if you can't see it for whatever reason, it could seal a ½ inch.
It could potentially, yes. with unlimited material and unlimited time, it could, it could seal most things. But
Right.
but yeah, once again, that's not. No one can fit that into their schedule.
Understood. But if there is this one random, piece of sheathing that for whatever reason has a bad cut and is a half by or 3/8 hole there that no one saw, it will fill that hole.
Yes, and it's also with respect to where you are on your seal program, anyways. So that's kind of what you're looking at. Yes, anything up to that size, it's fine. But usually, as you mentioned before, most people wouldn't walk inside, but the person installing the system is typically, there's going to be someone inside, every 20 minutes, every half hour or so.
Oh, so you are walking in the structure as it's being sprayed to see what's going on.
Yep, yeah, because it's makes it easier to you can look at the computer software and you can start registering relative humidities inside the home. So if you're looking at that and you can see that one of the stations that is off above the garage, and we know that the garage itself got fully foamed in, the rest of the house was kind of a in just a little bit more of a standard structure or something like that. But it's also just a much smaller space that's been stuffed in versus the other stations, big wide open space. You can start seeing relative humidities change once that humidity starts tracking up. That could indicate a couple of things. One could be is that the air is completely saturated in there, just because it happens to be tighter in that section of the home. So
it's actually there's too much mist in the air, and now it's reading that as moisture.
Yeah. So the more mist that happens to start filling up and filtering into specific areas, that could indicate there's a lack of airflow in there, or maybe a system malfunction, but that just comes down to the installer and whoever's in there.
So if you see that on something, you'll walk over and investigate that. Okay, this room's really tight. We don't need as much material here. I'm going to turn this one off or turn it down or whatever it is.
Turn it off, turn it down, or just let's walk it out to the big wide open space over here that just doesn't look quite as dense. Yeah.
Let it do its thing. So interesting. So now we've sealed. So let's back up one step. So what is the prep? So let's pretend I'm at plaster. Plaster's hung and it's finished, right? What prep do you need to do prior to installing your system, or what does the builder need to do versus what you do?
So in the builder's interest to take anything in there, tools, whatever, pull it out. Then that's for a couple of reasons. One, sure, you can just throw a sheet of plastic over it, but as these houses get that much tighter and the air is saturated with the sealant, you kind of get like a wind washing effect within the home sometimes. And so it's kind of, one, pull anything out that you don't want to get a little thin coated mist of, some sealant on. But two would be, it also allows us just the most access to the exterior envelope as possible. So if they have everything piled up in a corner and maybe it's a problematic corner, one, it's going to be a bunch of air that's heading into the corner.
So clean job site, tools out of the way, full access, and you need to be there from an hour to how long?
And then so it could be a couple hours. Like I'd say it's either like a half day or a full day type of project.
Okay,
usually
so you're there a while.
So
you need to block off a day for you to do your thing.
Yes, it would either be one day or a half day. Just it depends on the size of the building, depends on the structure.
In general, this is AeroSeal day on my schedule. They're coming. Plaster's hung. It's finished. It's dry. I'm ready for them. I want to ensure. And the reason we're doing it then is because at that point, we can guarantee ourselves that we're going to meet the final blower door at the end.
Yes, we can guarantee that we're going to leave you in the position where, barring someone else coming drilling holes, knocking things out, that yes, we're going to leave you with a structure that once we're done testing it or done applying the system, that you're going to have a structure that is under depressurization, meeting the code threshold that that your tester needs this thing to be at. And
so let's talk about money. So what does that cost? Is it a cost per square foot? Is it a cost per job? How does that work?
So it's typically under a cost per square foot, but it's more than a few different factors. It depends on, once again, how many houses is the person building, a few different things, but it could range anywhere from, $1 a square foot to $1.50 a square foot and that's on general construction for the most part.
So the baseline is $1 or $1.50, and then can vary from there depending on the complexity of the project.
Yes, and then that's where, just once again, general construction at this point is moving towards the kind of more complex state at 100%. This point.
Yeah. So I had the opportunity to use this product a year and a half ago, almost now, on a project in Falmouth that we're building. And it was the first time using this system. I was very impressed. You know, we called ahead of time and said, yeah, do it at, plaster hung and finish. And I think that house went from like a 2.1 and we had them bring it down to like 0.85. We wanted to be at, 1 or under. And in the end, I think we were at 0.95 at the final bullet test. So definitely worked. I did not feel like, once it's done and dry, I didn't feel like I knew anything happened.
Yep. Yeah. So
there was no cleanup I needed to do, no residual, nothing was ruined. Other than I knew it happened, there was no visual evidence of it that I could find.
Yep. Yeah. Usually, if done at the correct point in construction, typically the most you'll really notice is, a sticky, tacky floor, slightly. So, which gets mixed in with all of the other dust, dirt, and debris in the construction process, and it's getting swept up. So, usually if you have an issue, it's more so on the installer error, I would say, where you faced a nozzle directly off of a wall, by accident, or someone hit it as they're walking through, things like that.
And it's spraying on the wall.
It's spraying on the wall and messing up the finish a little bit, and then you're stuck, shelling out to try and get someone to fix that after the fact. So that's kind of the primary target of don't let that happen.
Okay. So the biggest problem you could have is that maybe some plaster needs to come down and get replaced if something does go awry.
It would be that or your mechanical systems. So depending on how they're run, usually if
so all mechanicals are shut off, obviously, when you're working, right?
Yep.
And you're covering the vents with the plastic?
So plastic, and if you've ever seen duct leakage testing getting done by your HERS rater, they use sometimes they'll have the blue guys tape or the stuff directly from the manufacturers, but it's all the same. But that just goes on and covers up the ducts. So that'll cover up any of the supplies and returns.
So there's a fair amount of prep in these houses to get ready to spray.
There is, and that's usually, that's usually the longest portion of the work is going to be prepping the house appropriately. So it's you come in, you set up and that's including setting up the system itself within the home. So, and that's all part of the prep process. Once you get to the actual sealing process, just once again, different factors end up with different times. However, I'd say on the long end, maybe 4 hours or so
of actual
spraying and sealing.
Right.
Typically within that time frame, you can, assuming there's no large scale penetrations in there, you're going to bring that envelope nearing its kind of maximum tightness threshold.
Yeah, there's a point where it doesn't make any sense to try to get lower.
It doesn't make any sense. It's also, especially imagine on these very large projects, if you're going for a passive house or something along those lines, but it's just an extremely large volume that you're dealing with. And if you're getting down into a couple hundred CFM of airflow, you're talking about very, very minuscule threads of open airflow that's, in one area or another. And, portions of the building could just, it's just you're kind of spraying it and it's just dropping because there is no airflow to carry the stuff anymore.
Interesting. So you can see it visually.
Oh, yeah. So, when you're inside, when it's actually occurring, the tighter the better, obviously, for the purposes of the system install, but typically, and I'd say especially now more so than in the past within Massachusetts, where everything is going almost 1.5 and below for the most part, depending on what you're building with, you'll go inside and it's going to be an incredibly dense fog that's in there.
Interesting.
Because it's going out,
And do you ever see like a wisp heading towards an opening?
So you can, and we have actually. You can, I'd say honestly, audibly, you'd hear it first, usually. So in our experience on like a passive house construction, it's happening more so on larger multifamily projects.
Sure.
Where once again, you get 100 sets of hands in any given day inside these things as they're putting them up. So oversight is your supers and PMs can only do so much especially if you're building a complex of 11 buildings or something like that. You can fire this thing up and it starts kind of working its way through, and then all of a sudden there's just this one long gap of a 2-inch wide, just shaft that's kind of running up into the
Sure.
attic space, and
Right.
no one really noticed it. And after it starts filling in with a little bit of fog in there, you can walk around, and then assuming you're not listening to music or something, you can hear the airflow just rifling through these areas.
So you almost hear whistling like a.
Yeah, you can. Yeah, kind of like a windstorm. I mean, especially and that gets a
And
bit
that's
more
only
audible.
at how many? 200 pascals?
So I mean that's happened at about 100 pascals.
Okay.
We typically run it a bit higher with the newer systems
Okay.
and what we're doing
And
right
how
now.
much can you put? How much pressure can you put?
I mean, we've gone up to 200. We've gone a little bit above it. It's just at a certain point, you don't want to blow too much air into this thing because you don't. Once again, 100 sets of hands on a project, and you're getting in with the exterior sheathing. Maybe a window only had a couple of nails that are holding it in. You don't want something. You don't want something falling while you're in there. So
You don't want the window blowing out.
yeah, you don't
of
want
the
a
house.
window or a door falling off, and outside of our door. I mean, you can run it up to the point that
That'd be pretty funny, honestly.
it would, as long as no harm, no foul, but and it's so.
Yeah, we got it sealed 1.5. Wait, it just jumped to 5. Oh, we just lost a window.
And that's something that would be very typical during a seal too. Is like a lot of the coverings over attics or other are going to be tape and plastic.
Sure.
So I mean, so
sometimes those let go.
Sometimes
during the
those
process.
let go. You're sitting there and you can just see a giant spike, and you go, "Oh no, what happened?" You walk around the outside of the house first, real quick, just to make sure, and you go, "Oh, something let go on the inside." So let's get in there and check on it. Before it turns into the fact that it's like you're either
So
going into.
there's a lot of technical expertise, but this is an art form as well.
Yeah, there's a lot of once I mentioned there's just different nuances that go into
There's
it.
a little
as
bit
you're
of black
installing it.
magic.
Yeah.
So you need to have a company that's had a lot of installs to have that empirical knowledge to say, okay, this is happening. I know to look for these 4 things, so that we're not doing on the job training. You've got to have that empirical knowledge to understand what's happening.
Yes, yeah, that's exactly. The more you do it, the more in tune you are with
Assuming you're paying attention.
Yeah, assuming you're paying attention, which and whoever is leading your crew is someone that needs to be paying attention. Everyone needs to be mindful. It's just so the cost of this system relative to the building options that you have, it's definitely a much more affordable way to achieve.
Oh, 100%, especially if now with this 1.5. The time to find out you're not at 1.5 is when you're at sheetrock, not when you're done with the house, because we're going to talk about that in a minute. So, right. So we're at plaster. I'm just going to use sheetrock for the conversation. So we're at plaster hung, finished, and we've brought you in. You've sealed it. You got me to 1.25 or 1. I know I'm good. I finished the job. I call my HERS rater. He comes out, does the final blower door test. I blow in at a 1.25. I need to be at a 1.5. Everybody's happy. We get it. That paperwork gets turned in, and we all move on. Now, I'm sure you've had scenarios where someone didn't want to spend $1 or $1.50 a square foot, and went to get their blower door test, and they're blowing a 2.75, and they need to be at 1.5. Now what?
So at that point, as you could imagine, if you're going to
the house is finished.
Yeah, at finished rate. I'd say none of the installers that are doing this really want to do it for you. Like it's a real pain because now you're thinking about every finished surface in this house that is basically all of your woodwork, your trim work, all of your finishes that are in there, floors, absolutely everything. It now needs to be covered and covered appropriately. So sure, it's not going to stick to any vertical surfaces, but imagine if it's a house that has a wall like this where you got some indentations on it and things like that. Like I personally, I wouldn't be comfortable blowing a house that has that unless that wall got covered entirely with plastic effectively. And
so the covering, the prep of that house after the fact is probably 10 times or 20 times the cost of doing it when it was just sheetrock hung.
I mean, maybe not quite 10 times. I guess depends on the size of the house.
I think it would be because we still have to pay you.
The cost of installing, yeah. I mean,
we have to pay you to come still. So now we're at $1, $1.50, but now we have to spend who knows how much in plastic and tape and labor and going around and covering every single finished surface. Every appliance, probably taking the appliances out of the building.
That's what we'd be saying. You'd want to recommend that they're either getting pulled out or if they're getting that, they'd be pulling to like the center of the room.
Yeah.
covered practically so that,
all wrapped up 100%.
wrapped up. So yeah, I mean, it depends on the house.
So that's a nightmare scenario.
It's a nightmare scenario. Have we done it? Yes. Pretty much any installer in the area that's doing it's probably had one or two of those types of projects where it's just kind of, someone has to do it. So this is the only option available to the builder, and, they're out of options. They're moving forward with it.
Now, so here's another scenario, and this came up when I had Andrew in from Energy Raiders.
Yep.
So, and I had never thought of this because I've done some high efficiency energy homes a long time ago. I don't want to tell you how long ago, but a long time ago. And he stated that a lot of the passive builders have their own blower door test and they're running it daily.
So some, yes. I mean, I'd say the ones that have been doing it a bit longer are approaching it in that manner. I would say there's right now, there's a lot of companies that are jumping into it because that's just what's dictating how they have to build now if they're going to build a certain threshold or a certain way.
And he stated that they want to know, okay, the plumber was here today and now I don't pass, now I'm at whatever, 5 air changes an hour. That guy drilled a hole somewhere. I got to go find it.
Yep. Yeah, so that's just the only way that you can really stay on top of it when you're talking about passive house. Passive house
it's a whole nother level.
It's a whole nother level.
But even on a normal construction, let's pretend I need to be at 1.5 and I've done a spray foam. Theoretically, I could own my own blower door, set it up, and say, okay, I'm good. Or, you know what, I need to call AeroBarrier. I'm blowing a 2 1/4. I have no idea where it's going. Get those guys over here.
Yep. Yeah. So, and I'd say, more so now than ever, for builders to have that available to them.
Because you're in big trouble if you don't meet that 1.5. Because at that, I mean, not only is it a nightmare scenario from a monetary standpoint, but generally the people think they're moving in.
Yeah. So right? Deadlines, timelines.
Timelines. They've sold the house now. They're homeless. They think they're moving in next week, and now you tell them, hey, full stop, we didn't make the air changes.
Yep, didn't make it, and stop your moving truck now, because this is the only route that we have options, for us right now. If you do get everything here, hey, we're in a position of,
So pro tip for all consumers, make sure your builder is doing AeroBarrier during an appropriate stage of construction.
Yep.
So that there's not a disaster after the fact. So if you're building a 3,000 square foot house, it might be adding $3,000 to $4,000 to the cost of the project. However, you're guaranteed, unless something silly happens near the end, which is probably going to be easy to find, the plumber went and drilled a new hole or whatever.
Yep.
We're going to pass that blower door test.
Yes.
And everybody's going to be happy. The moving truck's going to pull up, and they're going to move in, and they're going to wave, and you're going to leave and go on to your next job.
Yep. Exactly.
So there's no reason not to do it, other than you think you're going to make it and you're going to ride the lightning and save $4,000.
Yeah, it's that, or just someone that just, hey, my build profile is already there. I've been building this way for a while, so why add it now if I don't need to? So, which was just the line and train of thought that I was explaining before the actual energy code changes.
Sure.
For all builders effectively, but it's really that change in code. It changed more than a few things that builders are now stuck trying to figure out and navigate. So. I'd say no matter what, you're now just trying to figure out, well, my insulation profile has to change, or my window package has to change, or it's
right. But unless you're building the same thing over and over and over again, that you're riding the lightning that you're going to pass.
Certainly, yeah.
I mean, if you're in a subdivision, you're just building the same house over and over and over again, and you passed 5 times in a row.
Then you're comfortable with it. But then there's the others. Then yes, maybe you're comfortable with it. I would argue that I don't think anyone's truly comfortable with it right now at this point, unless it's the builder who has his own kit and he's just constantly monitoring this thing.
Right. So the last few that I've done, we've relied on years of experience, and we've had no problem. And we're building the smaller houses. I'm concentrating on the accessory dwelling units.
Yep.
We're going to talk about that in a minute. But that's an interesting, I had always done it, when the energy code changed last year, I said that, everybody at the company, we need to start doing this process for that reason, because we don't want to save, $3,000 and then cost ourselves $30,000 or more to try to fix a problem, plus have a customer that's going to be very upset because they've done the final walkthrough, everybody's happy, it's perfect, punch list done, and now we flunk.
Mm-hmm. Yes, worst case scenario for
Yeah, yeah.
for any builder
Well, everybody
for
involved,
everybody
right?
involved.
And then everybody's pointing fingers, and it gets ugly from there. So again, to everybody listening, don't be penny wise and pound foolish. There's some things you just have to do. So if your builder doesn't have this in his specs as a standard, you probably need to ask why.
I would definitely say so. And then, and right now I'd say some people are still kind of in that transition period a little bit because with the impending code change, a ton of permits were already pulled. They just want to make sure that they're falling under the code.
100%, yeah.
But they're kind of hitting that first run of houses that are under the new permitting process. And,
we have a few that are closing up now that were pulled under the old permit.
So, it's right now is the point to really assess. I'd say, you should have been doing it, this past year with knowing that code change was coming, figuring out some new maybe profiles or, talking with your HERS raters and seeing what should we be working on, what should we be focusing on, or asking, hey, on the next one I give you this set of plans to get that 42, what's the easiest change that I have here? And if they're saying, hey, we can shave a couple of points off just by getting this thing from a 3 to a 1.5 or even lower on some of them, then we can keep some similar build profile that's going on.
Yeah, so that's a good point. And I know I was focusing on the actual construction, but let's back up to the actual HERS profile, that HERS rating, right? So we're designing for, again, the minimum. Let's pretend the minimum on this build is 1.5, designed for 1.5. Maybe for whatever reason, there's a lot of windows or window to wall ratio, whatever that is, the numbers come out and says we need to be at 1.25 or 1 air change per hour. And now we've got a whole nother level of tightness we need to get to. So now in your profile, hey, I better bring these guys in because I want them to get it down to 0.8 during that process so that I guaranteed to get my 1 at the end.
Yep. Yes. And that's kind of what the aggressive builders that were trying to, kind of waver the storm a little bit better were the ones that were kind of doing that same exact thing right there. So they were just trying to see where they could bring their ratings down to one, even though they were still held to a 52 or the 55 on the previous code, and where ADUs are still currently sitting. They were the ones that were just trying to see, well, what can we do if we get to this, and effectively, can we just see what the limit is on my build? We just want you here for the day to spray this thing for 5 hours, just see how low we can get. Can we bring it down to like a 0.5 on your software? How does that translate to our end game? Because it's also, if you go a little bit lower on that test and say, hey, your goal was 1.5, but this thing pops out at a 0.9 because it just happened, that, the build profile that was put together that way was giving you a 0.9, and all of a sudden you're saving a few points for yourself elsewhere, where if, the exact mechanical system wasn't in stock that you purchased it, and then they run the serial numbers and say, hey, this one's actually going to be slightly less efficient than the model one here, which any of the builders...
gives you some safety factor.
Gives you a little bit of a safety factor. I would argue the tighter the better on these things. Once you hit a certain level, needs to be vented correctly. Yes, ERV, HRV, whatever. So, but at a certain point, if you can direct where the airflow is happening in this building, especially the tighter it gets, the better the lungs, ERVs, HRVs can operate within a home. If you have
and the other thing I've noticed, and this is newer for me because I hadn't done a lot of heat pump systems until recently, is that I've always had traditional fossil fuel systems, gas, oil, whatever it was, propane. And these newer systems, they just don't have that oomph that, you can have a house that's forced hot air gas, and you go away for the weekend, turn it down 55. You come in the house, it's chilly, you crank it to 68, and an hour later you're warm. Yep. You're not going to get that with a heat pump system. It just doesn't work that way.
No, it's
and
just...
so having the house tighter, even though we're controlling the ventilation, now the house is more conditioned, it's more comfortable, especially with these, what I would consider a low dynamic heat system where it doesn't have that hot air. You have warm air, but it's not hot. So we're keeping that air movement controlled. We're not losing leakage, and the system doesn't have to work as hard, obviously more efficiency, but I think it would be more conducive to a nicer feel in the house, if you will.
Certainly, yeah. Especially as it pertains to those types of systems, just because, well, what are they doing? They're constantly circulating that interior air.
Right.
So the tighter it is, the less natural leakage losses that you get, the less, the warmer the incoming air is during the winter time, the cooler it would happen to be during the summertime. So yeah, just overall, effectively improving the efficiency on those systems. I think a lot of people are aware that if you switch over to an entirely electric home without really assessing that envelope to begin with, and you get a leaky home, one, it's not quite as comfortable as you thought it would be, but two, you're going to look at your electric bill and go,
Yeah, I mean, if
geez.
you switch to heat pumps and you haven't handled your air changes, you're going to have trouble getting that house warm.
Yep. Yeah. So one, just trouble in the system, but then two, just operational costs of it.
Sure.
Are gonna be,
it's going to be on high all the time, and depending on the outdoor air temperature, maybe it's rated for -15, but because your house is so leaky, when it gets down to 0, it's really not throwing enough hot air because you have so much leakage.
Yep, correct.
Right. So all those things have to go hand in hand. So what's the longevity of this product when it's installed? There's no lifetime to it. It's inert. Like, does it break down after 20 years, 100 years?
So it's gone through simulated lab testing. So it's got its 50-year guarantee at this point.
Okay.
And I mean, as far as it, in the wild, it's only been around since, 2017, 2018 or so.
So fairly new.
It's still a fairly new product, but
Right.
the product that you could compare it to would be the duct sealing. So the duct sealing has been around for, a couple decades at this point, and that's a material that, as it's inspected, it's still holding up. It's still holding up within the ductwork that it's been installed.
Still
in.
pliable and
Still
hasn't turned
pliable.
brittle.
It's in, for what it is, anywhere that this does go in the house, it's never really installed in anywhere that's going to get direct sunlight. It's not going to be open and exposed for the most part. It's going to be hidden in darkness wherever it happens to be.
Right. So it kind of goes to its house and then it stays there.
Yep. Yes.
And it still remains flexible. So if the house shifts.
So if the house shifts, yes, it does remain flexible, and that's kind of one of the things when it comes to, like, I would argue it's like on a passive build or something, say or anyone that's using closed cell. I've seen plenty of projects where the closed cell goes in, and yes, it fills the cavity, it's there, but the house, there's going to be long-term settlement. There's going to be extenuating factors that
Right.
are pushing on that system, and it can create those little hairline cracks.
No, closed cell is awesome, but as you said, it's rigid, and if the house does move, it's not moving with the house. It's going to stay where it was.
Yeah, especially under like someone who's doing a deep energy retrofit. I guess any large scale renovation on an older home has to effectively be a deep energy retrofit now,
Sure.
just because it needs to come up to modern code. So like as you could imagine, like an old Victorian or something like that, where it's you're ripping down walls and then you're going to start foaming it in. Now imagine that this house is sitting on like an old fieldstone foundation or something like that, and
It's got frost heaves or whatever. Yeah.
Yep. So now it's been sitting there for a while, but then closed cell, it's pretty heavy material if you're going to spray foam the entirety of a structure there. So I mean, you're loading this house with a ton of additional weight, and then you get the additional weight once everything's moved back in. So I mean, you could imagine that there's probably going to be a little bit of shifting. It's an old home with old bones. It's going to throw everything off a little bit. And I think I have a feeling that was kind of one of the situations going on with a passive house project that we were involved with, where it was passing at a few different states where AeroBarrier is used a couple of times on it. So there's a couple of dealers actually in the area. We would just happen to be the last one to go in because of scheduling. But we did it at finish point in construction. But it's basically, it was a project that it had to get certified. There were no ifs, ands, or buts about it. It was going to get certified. So there was a few points in construction where it got foamed up and it had AeroBarrier, and it seemed like it was passing at a specific point. And then once again, it's an older home. There's probably some settlement here and there that maybe
so
threw
that's
some things out
interesting.
of
So
whack.
it had been treated multiple times, and then you still had to come back and treat it to get it over the goal line.
So that was just and that's on a very one-off type of specific project of
odd project.
A very, very old, once again, Victorian. It's
Yeah.
I believe that they're two houses. They're both certified. They got the passive and WUFI certifications. It passed all their air CFM thresholds that they needed for those two projects. I believe they're probably the only two in the world in terms of being passive house certified, Victorian renovations. So I don't think it's not too common.
that was a personal mission they were on in these particular cases.
Yep. Yeah. The client. It's one of those. Sometimes you get a client where
Yeah, yeah.
money's not a factor, but
They just want that.
Yeah, that's what they're paying for. Get it
Amen.
done. So, well, then there you go. Most standards of building and whatever you're allowed to do, and then the straw that broke the back is AeroBarrier, because it goes in, it's going to find the leakages. If you
Sure.
pressurize it and protect everything correctly, it's going to find the air leakage as it's heading out.
All right. So we talked about all the fun stuff. What's the bad stuff?
Well, it would just be, I mean, the bad stuff would just be a lack of monitoring by a builder post-seal.
Okay.
That's
he's letting
really, the bad stuff.
So again, just to set that stage, so we want to make sure all our exterior penetrations are done, all our wires are poked out, all the plumbing, spigots are poked out, whatever needs to be on that, any penetrations, hood vents, dryer vents, bathroom vents are done before we get you in the project.
Yep.
Right?
So yeah.
And if we don't do that, someone's going to go drill holes, and probably we're going to have a problem.
Yep. Yes. So that's yeah. So it's just monitoring of the system. It goes in a little bit earlier in construction. It doesn't go in at the end game, and
Right.
its certification on the system happens about dead last in the entire process of building.
100%.
The last thing that happens,
Yep.
is your HERS raters, and they're running their test and saying you're good. I'm going to file the paperwork. You get your CO.
Yeah.
So that's really it's the difference in timeline, where sometimes you can get in pretty early on this thing because you're going to go in at the rough end sheathing, like I was mentioning, or
Right.
you're going to go up right after sheetrock. And after each one of those, there's a whole succession of continuous work that's going to happen that that this system sometimes cannot fully account for.
Okay. So tell us. So let's switch gear for a minute. So tell us the makeup of your company, how many crews there are, capacity. I call you, how long before I see you? What does that look like?
See, on our end, so we're part of kind of an East Coast operations team. Right now, we've got 2-3 rigs in the general region right now, and just dependent upon the requirements by builders that are reaching out and getting involved. That's where you can start to scale it a little bit better. But we're able to work with our counterparts that are kind of scattered across the East Coast at this point now, being under AeroSeal's umbrella at this point. So it's a bit of a project-dependent requirement,
Okay.
but we're able to effectively.
So you can
scale.
ramp up and ramp down depending
Yep.
on the needs of the clients. And so when do I get you involved? Before I start construction, as soon as I have the HERS? Like, when do you want to get that phone call?
So, I mean, before construction's always best. The earlier you know, the better. Because in line with what we do, there's the HERS rater who can walk in, tell you what you need to do. If you have your installer that's coming in to work on this system, and especially where most, 90% of the contractors reaching out now, it's their first run on using this thing. So earlier in construction, the better, just so we can walk you through it and say, this is how you can set yourself up for success.
Tip. Give them the pro tips.
Yeah, pro tips, call early, let us know, hey, this is a HERS rating, our target is 1.5, that gives us a few things to start keying in on, because if you say, hey, I want it to be at a 1.5, but, the crew shows up the day of the work and the house is pulling a 10 or a 12 or something, you go, bigger issues here that you're going to have to really sort out now before we're going to 1.5 with this thing.
So a newer builder into this system, you're going to coach him through saying, make sure all the penetrations are done. Do this, do this, do this, do this, to set him up to succeed.
Yes, and that's kind of the
so you're acting as a consultant on the front end.
Yep.
And then you're actually coming and applying the product.
Yes.
And so what do I get from you when you're done?
So we're able to provide you with a seal certificate, and that's going to show you where it started and where it ended, duration of time, how much sealant you might have used, things like that. Percentage of air reduction, which is just starting, ending, things like that. So that's what we're able to provide you with.
So that's how we know that you did your job.
That's how you know that we did our job and that we're leaving you at a, there's effectively, depending, on your installer, you're going to say, hey, this is the range that this thing really needs to be getting to in order for us to have that post-test in a specific range for you at the end.
So you generally are going, 20% below where it needs to be?
Could be 20. I mean, it really, yes. It is builder dependent at this point right now.
Okay.
there's, different builders have different, they have their own ways of doing things. They have different, products that they're going to install.
That would never happen.
Never. Or, and just the way, even as simple differences on your, once again, as I mentioned it before, your little flapper packages that,
Sure,
some people will use some that are good. Some people are going to get the bulk order and pull them in and,
Right.
whatever
They don't
it
have
is.
a foam seal on them. And
Yeah, they don't
there's
have a
weak
seal
spring.
on them, weak springs, things like that. And, the worst thing that happens on our end is you do a project for someone and then they call back and say, well, I'm failing. What did I even pay you for? So that's the, prime goal number one is, certify your actions, cover your bases, make sure that you're doing things appropriately. And usually there is a level of some testing that may go on by the installers, either in the field or post seal. It could be, hey, if we're hitting this thing prior to your sheetrock going in, we run blower door tests. I've run, well over 1,000 of them myself. It's something that I'm pretty keen on doing, and I can show up and aid and kind of show, hey, this is where you're at now, especially at sheetrock.
Okay,
If we
so
got
you
in
can
early,
do some
things like that.
troubleshooting.
Yeah, we can do troubleshooting, and that's probably something that you do for, once again, a new builder you're onboarding.
Sure. Everybody needs to get up to speed.
Right? Everyone needs to get up to speed, but specifically in the Northeast region, Massachusetts entirely, it's everything goes through its inspection process, and majority of those inspections are, yes, this is meeting my code. The inspector says you're good to go. The troubleshooting was done prior by, your electrician, your plumber. They're testing their own stuff throughout it.
Sure.
This is the one system that gets installed. It's a little bit earlier in construction, and the only person who's going to certify it for you is that HERS rater when they come in and run their final test.
Right.
So it's a little bit different in terms of, I guess just general building practices. It's a newer system. And
so at the end of the day, and obviously you work for the company and you're installing this stuff, but at the end of the day, there's really, unless you're very confident you're building the same product over and over again, and you're confident in your installer and your installation and everything else, there's no reason not to do this.
No. I mean, not that I can think of. That's, just if you go through the whole host of, here's your options, this is what you're looking at now. Yes, this thing needs to be levels tighter than what you've typically done in the past.
Sure.
And
to go from a 3 to 1.5 is a big move.
That's a big move. And
it's not this, it's this.
Yes, and
right?
you or that way.
Yeah, you're right. Yeah, that way. Yeah.
No. But yeah, in terms of just levels of, like once you start getting into that, getting to a 2, usually you can find that. But like once you start saying, hey, 1.5 and lower, just
it's tough.
In my experience and yours as well, being a builder, it's not quite as easy as, hey, well, I have my design. Here's my,
all the little details come back to haunt you at that point.
Every little one. So, and that's just kind of what you're talking about. And you're talking about homes that need to get to a couple hundred CFM versus,
and
1,000 plus previously.
Especially the larger the house gets, the harder it gets, because there's typically a lot of construction detail. There's, flying rakes. There's, beams that are let in. There's all kinds of things going on. Extensive window packages. Overhangs, all kinds of things that are, a ton of detail, and that's where your trouble, can generally start. It needs to be addressed.
Yes, certainly. I guess just one quick one-off would be is we get a builder who religiously kind of finishes out at 2, but his build on this new one with his HERS rating, it needs to get to a 1. So,
right,
and that's even another level past 1.5 going and
one's
consistently.
Tough.
One is very tough.
Yeah.
And that's obviously just, once again, when you're looking at your build options of, it's a big home to spray foam, the entirety of it, it's, you're talking about an incredible amount of.
Yeah, but just because you spray foam, it doesn't mean you're going to make it either.
It doesn't, because the framing could, be built up a specific way. I think
spray foam does separate sometimes from the wall a little bit from the stud, right? That's why I've gone to the hybrid system where I'm doing 2 inches of closed cell and then, doing the open cell to give it that little bit more, a little more cushion, because I have seen, times when you have all closed cell, and it does sometimes develop a hairline crack along the face of that stud.
So yeah, and that and those cracks right there are kind of the issue when it comes to these tighter envelope, levels that we're trying to aim for now.
100%.
Which once you don't really have an option to skip out on, the official level for air tightness is what base code says. Hey, sure, it can be 3 air changes, but fat chance getting your HERS score down to a 42 or a 45
Right.
with 3 air changes.
Yeah,
and and that's obviously it's different for ADUs, but ADUs you're talking about it definitely gets that much harder when you're talking about a much smaller structure.
So it's interesting. So sometimes people think smaller is easier, and sometimes it can be harder. So let's pivot to that and talk about that. So I've got a 600 square foot ADU, and they have raised the HERS rating to 52, 55. Generally, most everything that I'm building is all electric, so now I'm at a 55. But I still have my air changes are part of that equation.
Yep.
So I have a 600 square foot structure. Does the $1 to $1.50 still work, or is it like a minimum charge?
So that's where sometimes it comes down to like a minimum charge, kind of just like a foam crew. It's you got to fire up a rig and send them out for a day, and it's.
Yeah, it makes sense.
A project like that, you could get away with one guy, but that's just the way the companies are built. There's probably a team of 2 that are typically operating any one truck. Yep. So probably looking at just kind of a baseline charge, even once you start getting down that small. And I guess just in terms of 3 air changes in a 600 square foot home is a much lower, CFM rate versus 3 air changes in a 1,200 or a 3,000. There's not a lot of room in there. So so you're still talking about a relatively, very low airflow threshold, which, certainly, foam and things like that can get you there pretty easily. Some attention to detail. Usually it's a little bit easier to follow some track some lines in a structure like that versus something larger. But then you mentioned you're going all electric, so now you're kind of back to that's where I kind of lean in on. Well, typically the tighter the better if you're going all electric.
100%.
So
where do you land on so let's pick on ADUs. Where do you land on the hot roof versus insulated ceiling on an ADU as far as air changes and overall energy efficiency?
So, I would just say, in my mind, probably because you're working with a really small, structure at that point, I'd say it probably depends on where you're going to probably stuff the mechanicals or systems
generally
like that.
We're on a crawl space.
So if you're on a crawl space and, you get that, that's properly conditioned down there, properly encased so that you don't have a ton of moisture buildup or anything like that, then sure, your mechanical systems can go there. I would typically kind of say if you're able to keep that roof line open and vented, then that can help you out with mitigating any issues that are getting in there to an extent. I mean it's gonna reduce the volume overall though, so that's where it gets even a little bit trickier when it's coming by that that number then. So then I kind of sit there and I don't mind either way. It doesn't matter too much. If you do foam the roof line, typically, once again, it's
yeah. I think for me, I've kind of landed on that, and I'll tell you why. So, not to go too far down the rabbit hole, but for the most part, we're not going to be able to have a full basement under these onto these ADUs because of the way they're calculating the gross floor area, right? So let's pretend we're stuck on a crawl space and it's properly conditioned. But the problem is now we don't have any storage, right? So I'm actually leaning towards raising the roof pitch and, either doing, a higher end pull down that can operate in a smaller area, not a traditional fold down one, but one of the new accordion ones.
Yep.
And now we have, if we do the rafters, maybe you can't stand up in there, but there's a lot of room to get up in there and store stuff.
Yes, and then you'd want conditioned storage too as well.
100%.
Plus, or just in the general.
And in that scenario, I would put the equipment up there off to one side.
Yes, yeah. So wherever it makes it easiest in terms of access, because obviously crawl spaces, if you're dealing with
you can do it, but no one, the tech that shows up to work on it's not going to be happy.
Got that right. So and
get down in the hole.
Yeah, and just the general way that a lot of these ADUs that we get involved with or that we see they're getting built anyways, it's that gives you an opportunity for a loft or something like that anyways, right. Or just maximizing the square foot in an ADU. I'd say you want to maximize the volume into livable, habitable space probably as much as you want or as much as you possibly can.
Interesting. Yeah, the loft thing makes me nervous because generally it's one of those crazy ladders that's straight up.
Yeah, I've seen those ones.
Yeah, and that just honestly that scares the hell out of me. I can just see somebody slipping off of that and getting seriously hurt or killed. And generally, my clients are generally, they all want to be on one level for a reason, and they don't want a ship ladder in their house. But they obviously, people have stuff, right, and they need a place to put it. And the attic seems like the most bang for the buck for me. We do spend a little more money, obviously, making a hot roof and raising the pitch, but we pick up relatively inexpensive storage and get our equipment up. If we're doing a ducted system, if we're doing, a cassette or a wall mounted, that's a different scenario. But if we're doing a ducted system, we get that up out of the crawl space. So I think that's where I'm kind of landing. I have a couple coming up, with that scenario, and I've been, working that back and forth.
Back and forth. I mean, yeah, you can go with that, or just generally opening up the space a tiny bit more for whoever's living in there if they don't want to have.
Well, I'm doing all 9-foot ceilings.
So perfect. Yeah.
Or ceilings, the smaller ones I've been doing 8 foot, but then vaulting the collar ties. So you have a slope and you get 9 feet or 9.5 feet in the middle and slope. But just give you some volume, to get that feel. But obviously when you do that, it cuts down the attic storage. So everything is a plus and minus, right? It's a small space and you're fighting for inches. So you got to pick your poison. Well, so any parting thoughts before I go into? I'm going to take you in the lightning round.
A lightning round, perfect.
Yeah.
Nothing major. It's more so. I guess the ending thoughts here would be is if you're a builder that's working in Massachusetts or anywhere in the area in the Northeast, start thinking about or game planning how you're going to meet those requirements. I mean, once again, the first person you're ever going to talk to is probably going to be your HERS rater. Right. You need that for getting your permitting. But come up with a good, viable game plan on your air barrier for these structures.
And just a quick segue. So I call you up, email you my plans. You can look at the plans and say it's going to be this much a square foot.
Yep.
Okay. So that's a relatively quick turnaround for me to build my budget for my project.
Yep. Yeah. Quick turnaround. It's effectively just pricing from plans. Barring any drastic changes in square footage or some additional volume or something like that. It's really
okay. All right. Good stuff. So here we go. The lightning round. Favorite tool you can't live without, and it can't be your phone.
It'd be Impact Driver. Makita, cordless. Yeah, the Makita. The amount of times that thing's been used, I've had that one I've had that since that first job that I was
really.
Mentioning. Yes,
all right. One of the OGs.
It's been around for some time. Needs a new battery though.
All right, industry trends you've noticed.
Well, everything's getting tighter. I mean, check it out. Yeah, that's one of the
So where do you think we're going? What's the next evolution of that tightness?
Probably not just the tightness, but it's just the higher efficiency builds, game planning towards net zero or net zero ready types of construction. That just seems to be where they're tracking everything to eventually be on par with that type of building.
Yeah. Dream project you'd love to work on?
Pretty much any of the nice coastal, either in the South Coast, especially Rhode Island, or any of those, a couple, those types of, I'd say those larger, mansion type projects that have a little bit of a longer standing, I'd say just timeline for production on those builds right across the ocean. It's something like that. Somewhere either that or maybe a nice cool cabin up in the mountain or something like that.
All right.
Just location wise, I'd say.
Okay. So I'm taking you'd go and install that yourself.
Yeah. I've got the experience in it. I've spent most of my time doing that.
There you go. I'm going to take this one. You guys stay home.
Yep. Yeah. You guys are going to hang around here. I got the extra truck. I'll be up there.
There you go. Best piece of advice you've ever received?
I guess probably keep quiet and assess the situation before speaking. To an extent, it's listen and learn.
All right, good. Advice you would give your younger self?
Get some knee pads for protection when you're crawling through all these job sites.
Take care of your knees.
Take care of your knees. Take care of your knees.
That's good advice. All right, then a fun one. Favorite food and dessert?
I don't know. man, that's one of those questions. What are you feeling right now? You know,
I don't know. What are you feeling? I mean,
I guess favorite food, probably like a carne asada or something like that.
Okay.
From a decent Mexican
Nice.
restaurant.
And dessert?
Dessert, probably pretty standard with like a chocolate cake or something like that.
Okay.
Yeah.
All right. So you're not a foodie?
Not incredibly, no.
Okay.
No.
All right. We'll work on that.
Yeah.
All right. Well, that's it for today's episode. That's a wrap. Thank you, Alex from AeroSeal, for joining us. Please subscribe, like, and share if you enjoyed it. And we'll see you next week. And remember, just build, baby.